Hello everyone. In this video we will solve one of the most important question which is based on Buckingham pi theorem in dimensional analysis. So this theorem is most important theorem as per SPPU examination, which is asked in many examinations. So also in 2014 examination, December 2014 examination, it is asked for 6 marks. Many a times this question is asked for 8 to 10 marks as well. Okay, so we will see what is that numerical. The example is, conduct a dimensional analysis by Buckingham pi theorem and prove that the pressure drop in a venturimeter can be expressed by P is equal to rho v square function of small d upon capital D, where P is nothing but it is the pressure drop, V is the velocity at the inlet, and F is the fluid density. And capital D and small d, these are the diameters at inlet and throat respectively. So it is the problem statement. So in this statement, if you can see, there are two statements and one expressions. So this is one category of the numerical using the Buckingham pi theorem. In some case or in another category you can say, so there cannot be the expression. Here the expression is given, but in some case there cannot be expression. So that type of numerical can be asked for the 8 to 10 marks. Okay. So we will solve this numerical stepwise. Now step number 1 is to find the relationship between the all variables. So if you talk about the variables, so there are two types of variable. First one is the dependent variable and second one is the independent variable. So now what is the difference between the dependent variable and independent variable? So basically dependent variable are nothing but these are the variables which are dependent on some other variables. Okay. So for example, z is equal to x plus y. Okay. So value of z here is dependent on value of x as well as value of y. If you change the value of x, suppose if it is 2, and in another case if you changes it to 3, so the value of ultimate value of z changes. Similarly y also, if you change the value of y, the value of z changes. So it means the z is dependent on x and y. So this z we call as an dependent variable, whereas x and y we call as an independent variable. Okay. So in general, if you talk about any equation, so the left hand side portion of that equation, that is in our case that is pressure drop. So pressure drop is nothing but the dependent variable, and all the variables in general also, you remember this thing students, in all the equations, any type of equations, the variables which are to the right hand side are nothing but the independent variables. Okay. So we will write the given statement in variable forms. So this is as per the mathematics, that is dependent variable is equal to the function of the independent variable. So here f is nothing but it is the mathematical term function. Okay. So this is the first step, to write all the variables in function form, which is like this. Now step number 2 is to find the dimensions of the variables involved. So we are having basically 5 variables, 1 dependent variable and 4 independent variable. Okay. So there are 5 variables. So in next step, that is in step number 2, we will find out the dimensions of the equation first. So now in step number 2, we will find out the dimensions of each variables. So there are two ways to write down the dimensions. First way is with the help of the formula of that particular quantity, or you can write the dimensions with the help of unit of that particular quantity. Or third way is you can mug up the dimensions of the quantities, but the best way is to remember the unit, as we have to remember the unit at any cost. Okay. So we have to remember the unit. So with the help of the unit you can write down the dimensions. So I have written the dimensions of all the parameters with the help of their formulas and unit. Now step number 3 is to find the dimensionless pi terms. So Buckingham pi terms from the theorem is itself, or from the name of the theorem itself we can say. So this theorem is dependent on the dimensionless pi terms. So pi term is nothing but it is a dimensionless number. It is not the quantity, it is not the property, it is just a number which is used by the Buckingham to solve the dimensional analysis problems. So firstly we will write down the total number of variables that we will be denoting by small n, which is equal to 5, right, dependent as well as independent variable. Now next is the number of fundamental dimensions. So basically for our syllabus we are having 3 fundamental dimensions, that is length, that is length first, and mass second, and third one is the time. So these 3 are the fundamental dimension, so that we represented by small m, which is equal to 3. So by knowing small n value and small m value, we can find out the number of dimensionless pi terms, and the formula is given by Buckingham, which is n minus m, and it comes out to be 2. So to solve or to get the expression of venturimeter for pressure drop, we need 2 pi terms. So these 2 pi terms we can arrange in mathematical form in this way, that is function of pi 1 and pi 2 is equal to 0. So the only ultimate is right now to find out the value of pi 1 and pi 2 terms. So these 2 values we will be finding out in terms of dependent as well as independent variable by using the procedure of Buckingham pi theorem. Now the next step is, that is step number 4, to find the repeated variable. So to solve the Buckingham pi theorem, we need to find the repeated variables. So repeated variable will be chosen based on the number of fundamental dimensions. If we are using 3 fundamental dimensions, so there will be the 3 repeating variables. Okay, so the value of fundamental dimensions with us is 3, that is LMT. So it means we need to choose, or we need to write 3 repeated variables from the independent variable. So, and remember one more thing, dependent variable can never be the repeating variables. Okay, so in step number 4, for finding the repeating variable, now we will see how to find the repeating variables. Now to find the repeating variables from the independent variables, so there should be the dimension from each of these 3 properties. First one is the geometric property, second one is the flow property, and third one is the fluid property. So these are the 3 basic properties in which our whole physical quantities are divided. If we see the basic of these properties, geometric property is nothing but these are the properties which involves the linear measurement. For example, length, head, or you can say area, or you can say volume. So these are the linear measurements, or you can say geometric measurements. So such properties comes under the geometric property. So in our case, the diameter. So we basically are having 2 types of diameter, capital D and small d. So any one you can choose, capital D or small d, you will get the same answer. So I have chosen as capital D as the geometric property quantity. Now second one is the flow property. Flow property is nothing but these are the variables, the quantities comes under this property is nothing but these are the quantities which involves or which comes into the picture when there is a flow. For example, velocity. When there is no flow, there will not be any velocity. Okay. So whenever there is a flow, then only there comes the velocity. So flow property are those properties which comes into the picture when there is existence of the flow. So velocity is available with us in our problem statement. So V comes as the second flow property. Now third is the fluid property. So these are the properties in which characterize the property of the particular fluid, or which characterizes the fluid. That is, for example, mass density, or you can say weight density, or you can say viscosity. So these are the main properties of the any fluid. So fluid property is nothing but which defines the characterization of that particular fluid. So these are the definition of properties as stated on the screen. So we have selected the 3 repeating variables from these 3 properties, that is capital D, small v and rho. Okay. Suppose if there are only 2 properties available in your problem statement, maybe 2 geometric property and 1 flow property, and there is no fluid property, for example. In our case right now we are having all these fluid properties in our problem statement. Suppose in another case, if there is no fluid property available in the problem statement, but there are 2 properties of geometric. So in that case you can use both the geometric properties as 2 repeating variables. First geometric property as first repeating variable, second geometric property as the second repeating variable. For example, diameter and area both are given in the question. So you can select both properties as a geometric property instead of fluid property. And suppose third, it is flow property if it is given. So third you can select the flow property. So in this way also you can choose the repeating variables. And remember one thing, choosing the repeating variables and forming the pi terms is one of the important portion or one of the important part of the Buckingham pi theorem. So now next is we will find out the pi term. So to find, or you can say to create first, actually it is not finding. In next step we will be finding or solving the pi terms. Now firstly in step number 5 we will be creating the pi terms. So how we create the pi terms? So each pi terms is nothing but equal to m plus 1, that is fundamental dimension plus 1. So we are having 3 fundamental dimensions and 1 it is constant. So there are 4, means each pi terms must be having 4 variables. So among those 4 variables there should be the 3 repeating variables in both the pi terms or in both the dimensionless number. So we will write as it is dv rho as a dimensionless, as a repeating variable. Similarly dv rho as a repeating variable in pi 2 term. So now how to differentiate these two? So for differentiating these 2 pi terms for the repeating variable, we will be giving the different powers. So for pi 1 we will be giving a1, b1, c1, and for pi 2 we will be giving the powers as a2, b2, c2. Remember, this is the standard procedure given by the Buckingham pi theorem. So except the pi term, except the repeating variables, now fourth term will be the compulsory non-repeating variables. So out of 5 variables with us, total 5 variables we are having, right, in this question. So 3 already we have selected. So there will be only 2 remaining variables. So those 2 we will be writing as a non-repeating variable, that is P for pressure drop and D for the diameter at throat. Now step number 6. So from here onwards it is purely mathematics. So we will see how to solve the pi terms one by one. First I will take pi 1, that is dv rho power a1, b1, c1 into p. Okay. So since whatever problem we are solving right now is it is the part of the dimensional analysis. So in the dimensional analysis it should be the dimensionally homogeneous, then only we can apply the technique of dimensional analysis. So dimensional analysis we will assume this equation as a dimensional homogeneous. So once the equation is dimensionally homogeneous, we can equate the dimensions of both the sides. Now firstly we will write the dimensions of all the parameters or all the variables. First one, pi terms. Pi, it is a dimensionless number, so that's why the dimensions are nothing but m power 0, l power 0 and t power 0. Now on the right hand side, d is the diameter. For diameter we can write as a length. For velocity dimensions it is l t power minus 1 whole power b1. Since the b1 is the power of velocity v, so it is bracket power b1. Similarly for rho and similarly for pressure drop. So these all dimensions we have written already in step number 2. Now we have to find out the powers of these repeating variables, that is a1, b1, c1. So since we know the equation is dimensionally homogeneous, so we can compare the powers. So firstly comparing the power of m. So on the left hand side there is no m, so we can write as in 0. So 0 is equal to, on right hand side there is only 2 m values. first m involves the power C1 and second m involves there is no power. Okay. So C1 we will write as it is, and here it is 1 bracket, there is nothing, it means it is 1. So 1 into 1 it is 1. So it is C1 plus 1. Okay. So from this 0 is equal to C1 plus 1 becomes the equation after comparing the powers of m. So from this comparison we will get the value of C1 as minus of 1. In the same manner we can compare the power of t first. So we can compare any power at any point of time. So you remember this trick also. Compare the power first, that power first who is having less variables. So if you compare t, so in this there is only one variable, but if you compare L, so there are 3 variables. It is not that much difficult also, it is very simple equation. So comparing the power of t first, 0 as it is to the left hand side, and on the right hand side t, there are 2 terms of t here in B1 and at the last. So B1 it is minus 1. So minus of B1 and at the last there is no power, means it is 1. So as it is minus 2, t power minus 2. So it becomes B1 is equal to minus of 2. Now third one is comparing the powers of L. So at the left hand side L ka power is 0, right hand side mein L power it is A1 first, plus in second term again there is a 1L, 1 into B1 becomes B1. Okay. Why we are taking it as an positive? Because all the terms in the right hand side it is in multiplication form. When we take it together, so it becomes in plus form. So we add all those powers in the right hand side. Okay, that's why it is plus. In third term there is L power minus 3, means it is minus of 3. So minus 3 into C1, minus 3 into C1 becomes minus of 3 C1, and minus of 1 it is from the last term L power minus 1. So in this way you will be getting the value of A1, B1 and C1. Okay. So all these values we will be substituting in pi 1 term. After substituting, this is the final expression. So now in the same manner we will solve for the pi 2. So first write down the pi 2, write down the repeating variables and their power and the non-repeating variable. So now next is to write the dimensions of all these variables. Okay. Now in the next step we will compare the powers of all the dimensions. Now first comparing the power of m. So it is 0 is equal to C2, and similarly for L it is 0 plus A1 plus B2 minus of 3 C2 plus 1. In the same manner T. So as we have found out the values of A1, B1, C1, so in the same manner here it is pure mathematics, simple basic mathematics only. We have to just add and subtract. Okay. So you will be getting value of A2 as minus 1, B2 as 0 and C2 as 0. So all these values we will be substituting in pi 2 term, and you will be getting this as an second expression, or you can say second dimensionless number, right. So after knowing both the pi terms, lastly we will substitute all those pi terms in equation number 1. So this is our equation number 1 which we have written earlier. Okay. So I have substituted both the pi terms, that is pi 1 and pi 2. Now here in this step I have just rearranged the equation. This portion I have kept as it is to the left hand side, and this parameter I have taken to the right hand side. So it will be taken to the right hand side as it is, because it is a function. Okay, it is a function, that's why we can take it as it is to the right hand side. Now next is the equation in the form of pressure drop. So rho into V square, if you take it to the right hand side, it goes into the numerator of that side. So rho into V square into function of small d upon capital D. So it is the final answer or final expression using the Buckingham pi theorem. Thank you.